and welcome to EMC's video on the VNX block data compression feature, which improves the capacity utilization in storage and helps lower the total cost of ownership. In this video, we will touch upon a few points, including learning what data compression is, highlighting VNX block data compression features, followed up with a demonstration on setting up and using block data compression in Unisphere. In today's world, capacity optimization is critical for companies that need to do more with less. By employing technologies like compression and deduplication, users can significantly increase storage utilization for the data. For those who are unaware, data compression is the process of reducing the size of a data file, which will ultimately result in improved effective capacity utilization from the freed up space. Compression is done by identifying redundancies in datasets, usually by comparing strings of data and removing them, leaving a portion of the original files. A good example for use of compression would be on a highly repetitive text document like a biological data collection of related species. Although, if that text document is continually changed on a daily basis, the data would have to be decompressed every time, resulting in poor usage of host I/O. This is why data compression is intended for relatively inactive datasets like archives, repositories, and backup copies, which are usually not accessed often. Now we'll move on to some of the features associated with VNX block data compression. In terms of processing, data is taken in 64 kilobyte increments, and compressed data is written to the corresponding LUN only if at least 8 kilobytes of data can be saved. Otherwise, the 64 kilobyte chunk is written to the LUN uncompressed. 8 kilobytes is the cutoff point for this operation because thin LUNs use an 8 kilobyte granularity and also allow the compression process to return space to the pool. This means that even though block compression can be done on any LUN, each LUN is converted to a thin LUN after the initial compression process. As the compression process runs, if enough 8 kilobyte blocks are freed up to make a 256 megabyte slice, then a slice can be returned to the pool for use by any LUN in that pool. The decompression process has a useful safeguard such that when a pool becomes 91% full during decompression, the state of the LUN will become system paused. Although, host I/O can still continue with the LUN in this state. This is implemented to ensure there is enough capacity for new host I/O. The state of the LUN can be overridden at this point, but if the continued decompression process gets the LUN to 98% full, the system pause state cannot be overridden. On a different note, block compression cannot be run if block data deduplication is enabled on the same LUN. This is due to the way each process is implemented and cannot be changed. Now we'll move on to a demonstration of setting up and using VNX block data compression. After logging into the VNX system and going into the control station, this is the view you will see in Unisphere. To enable compression, we'll navigate to the storage, then LUNs. As you can see here, a few LUNs have already been created, and to make it easier to see if compression is enabled on each LUN, we'll right-click on the information bar and add compression to the list. Now we can see that every LUN is not compressed, so let's change that. To compress a LUN, first click on the specified LUN and then click Properties. Next, click on the Compression tab and check the Turn On Compression box. Now we can select a rate, either low, medium, or high, which corresponds to how aggressively compression is performed, with medium being the default value. It is recommended to set the rate to low if response time critical applications are running on the storage system. We'll leave the rate at medium and click OK. We can now see that compression is turned on for this LUN. To monitor compression operations, click on the Compressed LUN Summary in the right-hand taskbar. Now let's try compressing a deduplicated LUN. As you can see, there is no compression tab, showing the inability to use the feature. For our last example, let's compress a thick LUN. We can see here that the LUN isn't thin, so now we'll turn on compression to show what happens. Navigating back to the LUN list, we can see that the LUN was converted to thin and compression is now on. For additional resources on VNX block data compression, please see the paper titled EMC VNX Deduplication and Compression on EMC Online Support.